I'm assuming you've watched the video, on product curves. And now what we're going to do is we're going to quickly show how we take the product curve information and we put it into, and we start figuring out what cost curves look like. So the information we have here is that, remember, this is our labor. That's our variable input. This is our total product. So this is what we're producing, the number of units we're producing. And then just hold off on these other columns for a second. So with the product curves, remember, we always assume we have at least one input fixed. And then given those fixed inputs, if we add variable input, it looks at how much output changes. And so this would be like if we hired one worker with the one factory and one machine, we get 3 units of output. If we hired 2 people, we would get 8 units of output. So what we're going to do here is we're going to assign like a cost to how much each person, each labor costs us. And our fixed costs are just whatever they are. So remember, our fixed inputs are some given. So we have fixed costs. For every fixed input, there's a fixed cost. So we're just going to make the assumption that with this one factory and one machine, let's say we pay rent every month. So the fixed cost for our fixed inputs we're saying is 1,000. So notice what happens here, whether we have one person working for us or no person working for us or 7 people working for us, our fixed costs don't change. So in essence, kind of like what's happened with the COVID-19, these companies that had to shut down, their variable costs could go to 0 if they had to lay people off. However, they still had to keep paying for their rent, for example. So they continue to have fixed costs. And this is why so many companies got into trouble when they had to shut down. So fixed costs are some amount in the short run. Those are the costs that you have to pay that you can't get out of until, let's say, your contract is up or something. So our fixed costs don't change, but variable costs do change because it depends on how many, in our case, people we're hiring. And then to get total costs, you take the variable and the fixed and add them together. So what we're doing in this slide here is we're going to assume, what are we assuming here? That we are paying each worker. We're making it easy. We're saying we're just going to pay each person $100. So in order to get our variable costs, we would say, okay, you pay $100 for however many people that we hire. So if you hire nobody and you pay 100 to nobody, your variable cost is nothing, no variable cost. If you hire one person at $100, your variable cost is 100. If you hire 2 people at $100 a piece, 200, and so forth. So we have this column of fixed costs, which is a given. We're able to get our variable costs. Why? Because our product curve told us that for some number of variable and fixed inputs, this is the amount of output we can get. So we know now that for $200 in variable costs and $1,000 in fixed costs, we're going to be able to produce 8 units of output. You can't get that information if you don't know your product curves. So again, the only way that you can figure anything out with costs is you first have to know your product curves. So if we wanted to produce 30 units of output, okay, it would be that, in this case, it would be 5 workers, we 500 in variable costs with $1,000 in fixed costs. And then we also have that, we're at the max, the 6 units, it could cost us this amount. So in order to get total costs, we just add the 2 columns together. So we're now able to say, for $1,000, if we had $1,000 in costs, we would get no production. For $1,300 in costs, we would get an output of 15. And so what we do is we take this information of relationship between our costs and our actual production, and it gives us, which we had shown, actually we'll just jump right to it, our cost curves. So what we find is that our fixed cost is some given straight line. It doesn't change. So it would be, in this case, like that would be that 1,000 $1,000. It's a given. So whether we produce 0 or 100, it's $1,000. Our variable costs, as you notice, keep going up because as you hire more and more people, your costs go up. So our total cost is the difference between our variable and our fixed. So the difference between these two lines, the total and the variable, is the fixed. So total costs, the formula for total costs is your total variable cost plus your total fixed cost. So what you do is you add to your variable cost curve the $1,000 at every point. So it gives us total costs. Now what we find in economics is that we actually don't use, well we do, but the ones that we use, like when we study all our market structures, is we, rather than using the total cost curves, we use our averages. And so what we're going to do, I'm going to jump down back to where we're going to take our cost curves, and we're now going to figure out all these other columns. And it's these columns here, the marginal cost, the average total, average fixed, and average variable. Those are the cost curves that we use to study our market structures. So how do we do this? Well, how do we get total costs? Well, you take your fixed and your variable and add them together. So that would be 1,000. You take your fixed and your variable, and that would be 1,240. Your fixed and your variable, 1,430. I'll just do a couple more, 1,670. And so notice everything we're doing here, we're just adding, you know, whoops, we're just adding the $1,000 to every variable cost. So this tells us if we want to produce 4 units of output, it's going to cost us $1,960. Now, in economics, we want a little more information of than that. So we're going to look at marginal, average, average fixed, and average variable. So this slide 39, very important that you understand and know these formulas. You've got to know these formulas. So slide 39, you've got to know the formulas. So we know total fixed is just the total fixed cost. It's the cost that doesn't change. Your variable costs are going to change based on however many number of people that you're hiring. Your total costs are the combination of the fixed and the variable added together. And then we have these other ideas. We have marginal, averages, and so forth. So your marginal is the extra cost. So like with marginal product, we were looking at extra output. Marginal cost, we're looking at extra cost. So what's the extra cost to produce some unit of output? That's what marginal is going to tell us. What's the average total cost? Well, it's your total cost divided by some quantity, where in the cost curves, your quantity is now your output. So be very careful of that. Don't confuse product curves and cost curves. So remember, product curves are looking at the different combinations of the inputs to produce some output, while your cost curves take that information, use that information, and look at the relationship between producing some amount of output and what it costs you now. So be very careful of that. So we add, as we were doing here, we add the fixed and the variable to get our total column. That's all we're doing. And then we have these other 4. Now, I'm going to just caution you here. You do have a homework question. Be sure you watch the YouTube or kind of help you or try to help you on how to do the homework question. But for exam, you're not necessarily going to be given a chart on this cost curve. What you'll be given are actual diagrams that we'll be looking at. But in order to use the diagram, you've got to understand where these numbers are coming from. But by the end of this, you're going to see why we use the diagram, because it's much easier to use that than trying to do it with this chart, which is quite cumbersome. Okay. So how did we get this column here, marginal cost? Well, remember, marginal cost is the change. How much does our total cost change when we change, in this case, our output level? What's the cost? What's the incremental cost change? So if we go and you have to use for marginal, it's the change in total cost, okay? So this formula right here, over the change in our output. So when we go from 0 to 1 output, the change in the output is 1, and the change in the cost was 1,000, and now it's 1,240. So the change in the cost was 240 divided by the output change of 1, so it's 240. So what this is telling you is to produce 1 more unit of output from 0 to 1, that costs you $240 that first unit. So think about that. That $1,000 in fixed cost, you can kind of think about as it's that cost that you have to pay no matter what. It's that sunk cost. It's the cost you're paying no matter what. So whether, meaning even when you have nothing, you're having to pay that $1,000. So the actual cost of producing 1 more unit in this case is $240 because you're paying that $1,000 no matter what. Okay, if we want to know what the extra cost is to produce the second unit of output, we would take how much does our cost change by from here to here, so 190 divided by the change in the output. So I've just made it increments of 1. So that would be 190. So that tells us that by producing 1 more unit of output from 1 to 2, the extra cost is $190. And then we just keep on going down. So notice the costs go down, 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 hit a point, and then go up, up, up. And if you go back to your marginal product curve, you'll remember your marginal product, the extra production went up, 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 hit a point, then went down, down, down. So this is the inverse, if you like, of the product curve. So the extra output went up, hit a point, then went down. So if you look at it from a cost standpoint, as your extra output's going up, your extra costs are going down, hits a point, then the costs go up, because your extra output's going down. So there's no mistake is the point here on this relationship. There are mathematical relationships between the product curves and the cost curves as well. Then to get the average total cost, you take your total cost and you're going to just divide it by some quantity. So remember, in costs, it's the output that's being produced. And so we would just go, you know, the total cost is 1,240 divided by 1. And then here, the total cost is 1,430 divided by 2, 67, and so forth. So we get on average at some quantity, what each of those units is costing us. And then we can separate it out, and we can figure out, continue on. We can then figure out, you know, what's our average fixed cost and what's our average variable cost. So in order to do that, you would take your total fixed costs and divide it by the output, because an average is just some total over some quantity. So if you want average fixed, it's the total fixed over the quantity. So notice what happens interestingly with the fixed cost average. Because the total is, in this case, $1,000, no matter how many units you produce, right, whether you produce 10, 2, 3, your fixed costs are the same amount. They're 1,000. So if you take the same number on top, 1,000, and divide it by bigger and bigger units, the average fixed cost will always drop. So this is a nice example, like the airline industry, why they're suffering so much now during COVID-19. They have a certain amount of fixed costs. So whether that plane is full or if that plane has 5 people on it, unfortunately, their fixed costs are some amount and they're high. So in order for airline industry to be able to get their costs to go down, they've got to have a large number of people on that airplane, because their total fixed costs are pretty high. They're the same whether they're at capacity on the plane or not. So, and this is kind of that idea, is that whether or not, no matter what your output is, your fixed costs are always going to be the same. So in order to get your average fixed cost down, you've got to get lots and lots of quantity. And if you don't, your average fixed is going to stay pretty high. So you want to be sure that you understand, you know, how you interpret and read what this is telling you. And then the last thing we would do is, when you go to this column, is we do the same thing for variable costs. So since we want the average variable cost, you're going to take the total variable cost column and divide it now by the Q. And that will give you the average variable cost. So the way you would interpret this is you would say at 3 units of output, our total costs are 550, oh, actually, let me do an even number. Let's say output of 4 units, our total costs are 1,960. This one says that the 4th unit costs 290 to produce. This tells us the average of each of those 4 units to produce is $490 in total costs. This says of that total $490, each of the 4 units being produced is $250 in fixed costs on average and $240 on average in variable costs. So if you add 250 and 240, that gives you the average total cost. So what we see is total costs are equal to total fixed and total variable. Average total costs are average fixed plus average variable added together. So you want to be able to know what each of these things mean. Now, as I mentioned, the relationship between the marginal cost curves and the average cost curves all go back to the relationship between marginal and average in your product curves. They're the flip side of one another. That's kind of what I was referring to before. You know, your marginal product goes up, 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 hits a point and goes down and down. So your extra output as you hire more people keeps increasing. So that means your costs are going down because you're getting way more extra output. Hits a point, then your extra output goes down. So that means your extra costs will go up. So they're the inverse of one another. So if we plot out our average cost curves now, so rather than the total, we now plot out our average. This is what ends up happening. They end up looking like this. Your marginal goes down, 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 hits a point and goes up. Our average goes down, 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 hits a point and goes up. And our average goes down, 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 hits a point and then goes up. So if you revert back to, I'm going to flip to it, the table, oh, actually this slide 47, you'll see that's what's happening. That your average total goes down, 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 hits a point. So down, 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 hits a point, and then starts going back up. Your marginal goes down, down, then starts going back up. And average variable goes down, 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 hits a point, and then starts tracking back up. The only one that keeps on going down, down, down is going to be your average fixed cost. Why? Because the fixed number on top, as you divide it by a higher and higher number, gets closer and closer to 0. And notice when we draw the curves, we don't draw an average fixed cost curve because we can figure out average fixed because it's the difference between, remember, your average total cost, right, is equal to average variable plus average fixed cost. So the difference between these two, the average total and average variable, is going to always be your average fixed anyway. So you won't see an average fixed cost drawn on any of the pictures. All right. So, and then we have that relationship between marginal and average. So here, this is what you kind of got to get used to, okay, is how to interpret and read this. So if I asked you a question and said, okay, at an output of 100, so Q of 100, I want to know what is average total cost, what is average variable cost, what's total cost, and so forth, you would actually be able to do it with this information. So how you would read this is you would say, oh, at Q of 100, we come on up, you go over to this, and you see 7. So this $7 right here is your average total cost at Q of 100. This $3 thing here represents our average variable cost at Q of 100. And then this well, I haven't given it, so we'll just stay with that. So we can see here now that at Q of 100, our average total cost is 7, and at Q of 100, our average variable cost is 3. What's our average fixed? Well, remember the difference between these two, average total and average variable, that is average fixed. So that would be $4. So the difference between these two things. So types of questions you would have would be from that diagram, you know, at Q of 100, what's given average total 7, average variable 3. How do we get this? Okay, so how do we get this? Well, remember, I'm just going to make a note that average total cost is the combination of average variable plus average fixed. And then I'm also going to note that total costs are equal to total variable cost plus total fixed cost. You've got to know, remember these formulas. You've got to know them. So if I ask what's average fixed cost at Q of 100, it's going to be the difference between, right, the average total cost and average variable, which in this case is equal to 4. So 4 and 3 will equal 7. What's total cost at Q of 100? Well, how do we know this? Well, if we know, we know the average fixed cost is 4, which tells us on average, each of the 100 units costs $4 in total fixed cost. That's what that number says. We know that average fixed cost is $4 at that Q of 100. So if each of the 100 units is $4 on average, then we can do the following. We can say total fixed cost is average fixed cost times Q, which is $4 times 100, which is $400. I prefer to just think about it in my mind. If I know on average each one costs $4 in fixed costs on average, and I have 100 of them, it's 4 times 100. How do we get total cost? Well, we know average total cost is $7. So on average, each of the 100 units costs $7, each of them. So 100 times 7 is $700. Or if you prefer the formula, it's average total cost times Q is going to equal your total cost. How do we get total variable costs? Well, we know on average, each of the 100 units costs $3 in variable costs. That's on average. So 100 times 3 equals $300, or it's, if you like the formula, it would be average variable times Q equals total variable cost. And we already figured out our fixed costs. They're 400. And what do we know about fixed? Well, they don't change. So when I ask you what's total fixed cost at 200, we already figured out what our fixed costs are. So fixed costs don't change. So they remain at $400. What is average fixed cost at 200? Now this one's, be very careful. This is average fixed cost. So remember, average fixed cost is total fixed cost divided by Q. So that you do have to figure out. So we know that total fixed costs are 400. Our output is 200, so that would be $2. Whoops, be $2. This one, what if I tell you marginal cost at the 6 unit, is $6 at the 300 units? What is total cost? So this tells us the 6 unit costs, excuse me, I'm saying that wrong. This tells us the 300th unit costs us $6 to produce, right? That's what it tells us. And that is it. It doesn't tell us anything else. Marginal is very precise information. It tells us exactly what the cost is of an exact unit, which is really important information if you're trying to decide if you should produce that 6 unit. But in this instance, when we want to go further and say what's total cost, it's not going to help us. So can we say or find total costs here? No. The only way we could have done it is if I'd given you the average total cost or some other information. So I would practice on this. So again, here's another one. Quantity of 100, you come on up, you go to your average total cost, you're told it's 10. At quantity of 100, you come on up to average variable cost, you're told it's 5. So we know, again, from that diagram, you'll be given a set of questions where you'll have to figure out, you know, what is the average total, average variable, the total cost, and so forth. And then I have the areas too. So just as a quick little note. So the area would be what's representing. So at Q of 100, you come up here. Let me label this. This is going to be our average total cost. And then this is our average variable cost. Okay, so if I want to know what my total cost area is, we know that from 0 to 100, okay, each of these 100 units costs $10 in average total cost. So each of these units costs us $10 on average. So total costs are 10 times 100. So the area would be, if you watch my mouse here, it would be this whole thing here. It'd be from here to A down to 100 to 0. That's the area. For the variable costs at 100, you come on up over, so on average, each of these 100 units costs $5 in variable costs. So 5 times 100 is 500 in variable, so the area would be this box here. And then for the fixed cost, remember the difference between total and variable, that difference, the difference between these curves is average fixed. So it would be the difference between these two is also 5. So the average fixed would be that box. So the average fixed box and the average variable box, or excuse me, I'm saying that wrong. The total, the box represents the total. So the total variable costs and the total fixed costs give us the total costs. And to get the averages, you just simply will read off of the actual diagram. So you'll want to practice this slide and make sure you're able to produce this. Same with this. You want to practice slide 58 and be sure that you're able to do this, and you'll be able to. So this is a nice example of taking the product curves and figuring out how we get the different costs from those things. All right. So again, we have 3 time frames. We have short run, we have long run, and then we have the very long run. So everything we have done thus far has all represented the short run. So that's where we have at least one input fixed. And that's where the product comes from. It's the daily operations of the company, and that's what gave us our short run cost curves, which is what we've been looking at. Okay, there's another time frame in economics, and that's called the long run cost curves. And always, again, keep in mind, long run in economics has nothing to do with an exact time. It could actually be 30 years. Or we define long run in economics is where, or short run, excuse me, short run could be 30 years. If we say at least one input's fixed and we don't change any input for 30 years, that's still short run. So again, it's not about time, it's about inputs. So when we look at long run, we're saying all inputs can change. And so what it kind of would be the idea is, it looks a little abstract here, but this would be like if you're a company starting now, you have one store. The first store you have is you have a set of cost curves with just one store, and you hire different numbers of people, and you get your product curves, which would then give you, your first cost curve with just having one store. Then you decide you want to expand and have 2 stores. So now you've got a different set of cost curves. So this is with 2 stores, a new set of cost curves, because obviously you have more expenses now. And this, what we're doing here, it might seem a little weird at first, but this line along or around these different cost curves are the long run cost curve. So let me just continue on. So like if we open and we have 3 stores, we have a new set of cost curves. If we had 4 stores, a new set of cost curves. We get to 6 stores, we have a new set of cost curves. So what the long run cost curves are, first of all, is it's the minimum points of all these different cost curves, whether the person has 1 store, 2 stores, 3 stores, 4, 5, 6, or 7. So the long run cost curve, first of all, is the minimum points of all the short run cost curves that this firm could have. And what you'll notice is in the long run, as we expand, notice the costs go down. So the costs for this company are going down. And then they hit some point where it could stay the same. And then it hits another point where all of a sudden the costs start rising again. So what we think that we would want to do is always produce at the lowest cost curve. But we're actually going to see, sometimes that's not always the case, but actually, I don't know why I put that there. Let's just hold off on this for just a moment. So the areas. So the economies of scale where the costs are going down, 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 down. So sorry, let me backtrack, going down, 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 down. That would be the place where, as the company is expanding, so they go from 1 store to 2 stores, the cost per unit of output is declining as you produce more. Why? Well, because as you get bigger, you're able to buy things in bulk. And people or companies that can buy things in bulk, they don't have to pay as much per unit for those things. And so what it can do is it can improve or it can cause the cost per unit to go down. And then they can hit a point, and not all companies get to this, but from their theoretical, we also put it in, where you get to this place of having so many stores, whether you have 3, 4, 5, or 6, that your bulk rate doesn't change. So if you're buying, let's say, cheese, whether you buy 100 pounds or 400 pounds of cheese, your per unit price is the same. So it gets to a point where the costs, don't change. And then we have this really weird situation where, where we were at that, to show where we now have 6, 7, that could be 600, 700 stores. And all of a sudden, as you're expanding and growing, your costs are going up. So the question is, well, what would be causing that? Well, that's known as diseconomies of scale. It's the idea of that sometimes we can become too big. And if we become too big and we're not careful, companies can become very inefficient and they have too much red tape, poor management, or it may not even be poor management. It just becomes so big that it's actually really hard to manage the whole company. Bad communication, there's all kinds of ideas. So obviously, we never want a company to go to this area. But the point is that companies need to be aware that when they're looking into the thought of, expanding, they need to be aware that this is a possibility. This going into diseconomies of scale is absolutely a possibility that can occur to companies. The ideal place is to be, where we're able to keep our costs low. So if I were to say anything, obviously we never want to go to that place where we get diseconomies of scale, but also realizing as a firm that at times we might end up there. And if that happens, we need to, go through and figure out what we're doing wrong and fix things.